I think we can wind up. Can wind up by discussing this. Can wind up by discussing this. Yeah, break imeisha. Nilituenda break na mi kompyuta yangu ika disconnect. So next time stand up break. Nienda I think within 20 minutes we shall be through so that you can do whatever. Just. Hizo maswali sijui tunarejesa wapi, just hold on stop them. Kikubwa ni tusome, mambo ya kurejesa is not a priority for now. Okay. Mambo ya kurejesa sijui wapi just not a priority for now. Sasa kikubwa ni tusome kiasi. Let me just, I want to share my screen. Oh, my. Someone is saying I'm slow. Let me check on my mic again. I think within 20 minutes we shall be through with this class.
McDonald. McLee.
So we are going to study computer classification.
McLee.
Let me try and see if I can display this.
McD.
Let me see if I can share that.
McD.
Classification of computers. Yeah.
McDonald.
Yes. See, you can pick from there.
Am I audible now?
Umame, I think you can pick from there. Yes.
McD, am I audible? Are you getting me?
Yes, you are audible.
Yes?
You are audible, sir.
McD, unanipata?
Yes, I'm getting you. I'm getting you.
Are you online?
Nakupata.
Are we online now? Are we online or the students have left? So I can
Yes, we are live. We are live. We are live.
What have you been doing so far? Can you brief me?
No, we are online.
What have you been doing?
Yes, you can continue.
I have to log in.
We have just been reflecting on what you taught us last lessons.
Or you are refreshing? Okay, let me log in.
Yes.
I'm logging into the e-learning system. That's what is taking long, but
okay.
Let's... Makdi, can you display the notes from your side where we reached last time? This thing is taking long to open here.
Let me check. Let me check. Let me check.
Online, the online thing is site can't be reached. Don't know why the site can't be reached.
I'm trying to log in.
For me, I'm not even been able to see that online site. The site can't be reached.
Maybe you can. I think we were supposed to start on computer hardware.
Yes, now just display that. Because for me, I don't know if I'll be able to log in. It just says site can't be reached. So just display that and then I move.
Okay, let me try. Yeah, members were just trying to access, just trying to access the e-learning. Ni saa tatu, si klasi, next class inaanza saa tano. Acheki kama unafikiri uko na class nyingine saa hii, just enda. Sababu what I know as per the timetable, the next class start at 11. Najua sasa ukianza kusema tunajua unachelewa klasi zingine mazee. Mambo ya attendance tutasort baadaye. Mambo ya attendance tutasort baadaye. Okay. So meanwhile we were doing something. We were doing something. And we were doing something on classification of computers, I think. Yeah. Yes, too. So we were saying that traditionally we can classify computers according to their size. I'm just buying time so that the lecture logs in and maybe take us through something. Dr. Barasa, has it happened from your side?
Yes, I'm here.
Are you
Are you
able
able
to
to log in?
access? Yes? Okay, let me just check. Yeah, just hold on. Just hold on. We are getting things fixed here.
Mark, it's taking long to open that.
Just hold on. We are getting things
It's
fixed.
taking long to open the notes.
Yeah, sure.
I don't know what's happening.
Yeah.
I've clicked and nothing moves. Ah.
Yeah.
Have you been able to open on your side?
I'm also. Let me try. Or maybe you can just brief us. Maybe you can just brief us on the expectation on lesson 3 as we tried to do.
Okay, the
Just maybe
expectation
meanwhile,
in
just
lesson
brief
3
us.
is about hardware devices.
Yeah.
Issues to do with the central processing unit, the CPU, which has the ALU, arithmetic logic unit, control unit, which are very key in arithmetic operations. Then we are going to look at the storage devices and output devices. We'll also start with the output devices. That's like printers. We're also going to deal with them as part of the hardware, and the storage devices are part of the hardware devices that we are going to look at. Let me see how I can get these notes. Hardware. So when we talk about hardware, we talked about software. Software is more of physical, the intangible parts of the computer. Those are the software. But hardware is normally the tangible parts of a computer. They're actually tangible. So we have software and hardware is these are things you can touch, you can repair, and they are very key. McDonald, have you managed? Or it's hanging?
Yeah, just go. Maybe you can just brief us. Just maybe we just brief us
Let me
as
see
we
the older
prepare.
one. If it is.
Bado. Yeah.
So we have hardware. We have the central processing unit, CPU, which stands for central processing unit. It's also known as the brain of the computer. And a computer is primarily a component of a computer that performs most of the processing and controls the operation of all components running inside a computer. So we have the input unit, the input devices. We talked about the keyboard, the mouse. Those are input devices. The touch screen, we talked about them. Now we go to the CPU, which has the control unit, arithmetic logic unit. Then we have the output unit, and then we have the memory unit. So the key components of a computer are the control unit, ALU, and the memory. The alignment and integration of the components, as I've said, there are the three components. So the components of a CPU, which are very key, we have the control unit, the ALU, that's the arithmetic logic unit. Then we have the memory or storage unit. Then we have the registers. These are very important. So if you talk about the control unit, as a control unit acts as the brain of the computer. A major role of the control unit is to manage and execute instructions to perform the tasks specified by a computer program. So our CPU executes instructions by fetching them from memory, decodes them, then executes them. So it plays a vital role in fetch, decode, execute instructions. So it's very important for you can fetch, then you can decode, then you can execute instructions. So what are the main functions of the control unit? One is instruction fetch. A control unit fetches instructions from the random access memory. Then when you talk about instruction decoding, it decodes the fetched instructions to operate. Then instruction execution, a control unit sends control signals to perform operations like ALU and logic operations. So control flow management, it controls flow by updating the program counter. Then exception handling, a control unit effectively manages the exceptions and interruptions like hardware failure, system calls, and external events by appropriately diverting the control flow of the CPU to a planned procedure for managing such exceptions. They also help in synchronization. A control unit plays a crucial role in facilitating the coordination of instructions executed across several cores. Then we have what we call the control unit. The arithmetic logic unit, or ALU, is a component that has excessively optimized and engineered to do multiple tasks. It is commonly built to execute operations speedily. It works in conjunction with the CPU components, such as the register, the memory, and control units, to execute complex instructions. So the main functions, of course, of the ALU from the word arithmetic logic unit. So the first thing, it performs arithmetic operations. The ALU can perform arithmetic operations. It can also perform logic operations. The ALU can also perform logic operations like AND, OR, NOT, XOR, and bit shift sharing. So it can do logic operations. Then a memory unit. A memory unit is a hardware component which is used to store, access the data whenever required. Majorly, computer memory is categorized into two parts, primarily the primary memory, which is the RAM, and secondary memory, which is the hard disk. If you go to your computer, you have a RAM for your, not even for your computer, go to your smartphone, you have a RAM, and you have a storage memory, made a memory card or internal storage. Here they will call it secondary storage, which will be the hard disk, but here you have internal memory that is almost 64 GB or 30 what? 64, 32, or even if it's 20, depending on your phone. Some have 250. RAM is used for short-term fast data processing and is essential for active program execution. On the other hand, storage or secondary memory provides permanent data storage. So it's like there's an error. I think I'll use some online notes here.
I've shared on your WhatsApp. Just check on your WhatsApp, it's loading. Doc, check on your WhatsApp. Doc, check on your WhatsApp. Doc, check on your WhatsApp. Check on your WhatsApp.
McDonald?
Check on your WhatsApp. I have shared something on your WhatsApp.
Oh, just send on mail. WhatsApp is not the best. I'm not. My phone is a bit far. Let's put on mail.
Okay. Just now. Yeah, just refresh your mail. Just refresh your mail. You see it. Just refresh your mail.
So, having learned about what a computer is, in topic 1 and its history as well as the various types of computers, it's now important for us to have a glimpse inside the desktop. This includes to introduce the parts of a computer and also called computer system. It explores the computer hardware besides mentioning the types, after which you will be walked through each type of hardware in details. So I think we had talked about input devices last time. So I think we need to come to what we did not talk, because I remember we talked about input devices. If I can remember very well, we talked about input devices, we talked about this processing cycle. I remember we talked about all these input devices, the document readers, optical character recognition. We talked about time. We talked about magnetic ink character recognition. think we stopped somewhere here. Let me. We talked about Mikri. Let's move to what we did not talk about. I think we also talked about pointing devices, the mouse. Trackball, joysticks. Once we went through. Touch screen, the voice input digitizers, the scanners, the point of sale. So we are supposed to start on processing devices. So processing devices, the procedure that transforms raw data into useful information is called processing. To perform this transformation, the computer uses two components, the processor and the memory. The processor is like the brain of the computer. It organizes and carries out instructions that come from either the user or the software. In a personal computer, the processor is usually consists of one or more specialized chips called the microprocessor. These microprocessors are also called the central processing unit. So early personal computers were not much larger than a thumbnail, but processors such as Intel Pentium are considerably large. So the computers that you see, most of them, the Pentiums, the Intel Pentiums, the ones that you see desktops that we use sometimes, and the current computer, those are the desktop, they are a bit large, but with smartphones, they are a bit smaller and they're even better. So the CPU, the central processing unit, the CPU, receives data from input devices, processes it, and prepares information for output devices. Data should be entered into the computer with cards, terminal, or data collection devices. Data could be output on printers, cathode ray tubes, or video display terminals. So we have the input devices on your left. Then you have the central processing unit, which has the memory unit, ALU, and control unit. Then we have the output devices. So the function of the central processing unit is to perform all the processing, includes all computations, to control the sequence of operations, gives command to all parts of the computer system, controls the use of main memory storage to store data and instructions. The CPU consists of three components: the control unit, the arithmetic logic unit, the primary storage unit. Each unit has a particular function. So let's start with the control unit. As we start this discussion, we might say that the control unit is the major part of the CPU. The control unit essentially governs all the computer activities and monitors the execution of programs. It coordinates and controls such as the brain directs the body. The control unit executes program instructions to be fetched from the main memory via the MDR. MDR is a register and placed into the instruction register. So memory, address register, and the instruction register. So when data memory storage receives an appropriate signal from the control unit, it transfers the instruction whose address is specified in the MAR. This is a register into the processor's MDR via the data bus. I think you're going to see what MDR and IR are just as we move via what we call the data bus. So the control unit interprets the instructions in the instruction register, that's the IR, and causes the instruction to be executed by sending command signal to appropriate hardware. E.g., it might cause main storage to transfer data into the MDR, or it might cause the ALU to perform some operations on data registers. The cycle is then repeated with the next instruction being fetched. So before that, I just wanted to show you something. Before that, now we are going to reach on that. It's important to know that before we move. So we have the MDR. This is what I wanted to tell you. MDR is the memory data register. That's the memory data registers. Then memory address register is the MAR. it's important that you know the MAR and MDR, memory data register, and the memory address register. So that's what I wanted to show you there. Then let's move now. Let's continue from where we had left. It's here. So what we are saying, as we start to discuss, we might say that the control unit is the major part of the CPU. The control unit essentially governs all the computer activities and monitors the execution of the program. It coordinates and controls the computer system, much as the brain directs the body. The control unit executes program instruction to be fetched from the main memory via the memory data register and placed into the instruction register. When main memory storage receives an appropriate signal from the control unit, it transfers the instruction whose address is specified in the memory address register into the processor's memory data register via data bus. The control unit interprets the instruction in the instruction register and causes the instruction to be executed by sending command signals to the appropriate hardware devices. It might cause main memory to transfer data into the main data register, or it will cause the ALU or arithmetic logic unit to perform some operations on data register. The cycle is then repeated with the next instructions being fetched. So that's what you know, that's the role. Then we have the arithmetic logic unit. The next part of the CPU that is of great importance, especially during processing, is the arithmetic logic unit. Has two functions. It's responsible for performing all arithmetic, add, subtract, multiply, and divide. It performs all logic operations, testing whether data items match. Data items to be processed are taken from the main storage as directed by the control unit and passed to register into the data registers accumulators in the ALU where they are stored. This step is referred to as loading data into the data register from the main storage. It should be noted that at this point, the location address of this data will have been specified in the instruction register from where they will have been transferred to the memory address register prior to loading the data. So the ALU then performs the required operations on the data, e.g. adding, as directed by the control unit. The ALU leaves the results in a data register. While the ALU is carrying out the operations, it may make use of others on such as the operand and result register. For example, it may build up a result in the result register before sending the complete results to a designated data register. So the results are taken from the data register and placed in the main memory, again, under the instruction of the control unit. This step is referred to as storing data. So it means that we have registers that are here, very important, that help us. Data is not held in the air. It's held in some memory storage which is physical. So when data is put somewhere, like a number like 15 you have put, it will be put somewhere in a data register. Then the address will be memory address registers. Data will be transferred via to the memory address register to load the data. It's important to load the data once you're given instructions to load that data in an active place where at least calculations can be done. Once the calculations are done, again the data is stored in a register, and the register now takes back to the main memory where it can be stored. So that is the process. So that's how even your phone works. The primary storage unit, one might ask themselves, so where does all the data we introduce into the computer go? It will be interesting to learn that computers has storage units that stores all programs. Is one of the important components of a computer. Any storage unit of a computer is classified on the basis of the following criteria. One is access time. This is the time required to locate and retrieve data stored from the storage unit in response to the instruction. Storage capacity, it's the amount of data that can be stored in the storage unit, cost per bit of storage, and then unit of memory. The computer storage, the computer stores a character in the storage cells with a binary 0 or 1 mechanism. Thus, the basic unit of memory is a bit. A bit is, if you just write 0 or you write 1 or 0, that's a bit. The single smallest representation of data is a bit. Then a byte is a computer word. 0004 forms what we call a byte. 4 zeros, those are called a byte. 001 is equivalent to 1. 0001 is equivalent to 1, which is also a word, a computer word, which is called a byte. Byte is BYTE. To store a character, a computer requests 8 bits or 1 byte. So this is called the word length of the unit storage. So if there are 8 bits, 0000 up to 8, they are called, but also sometimes when they are 4, they are also called a byte because they form a word, like 0001 forms what we call a byte. That is a word. It is a full, it's a full word. It's 1. It represents 1. Hence, the storage capacity of the computer is measured in the number of words it can store and is expressed in terms of a byte. So the different units of measurement are. So this is how you get to know how kilobytes, and how you have bits, then kilobytes, then megabytes, then gigabytes. So if you have 8 bits, you form what we call a 1 byte. 1 byte is what we call 8 bits, 1 byte. Then 210 or 1024 bytes. That one we are talking about. That we are talking about 1024 bytes. If you have 1024 bytes, is equivalent to 1 kilobyte. And if you have 1024 kilobytes, it is equivalent to 1 megabyte. And if you have 1024 megabytes, is equals to 1 gigabyte. And if you have 1024 gigabytes, you have 1 tetrabyte. Tetrabyte. So that is how you convert. So for example, somebody can tell you, John had 100,000 megabytes of data. What amount of storage what amount when he John has 100,000 kilobytes of data. He wants to buy a flash disk. So what capacity of the flash disk in gigabytes can he buy? So you will do the conversion from kilobytes to gigabytes so that you can know the amount of, you have to convert that gigabyte. You have to convert the kilobytes into gigabytes so that John can be able to know the capacity of the flash disk is going to buy. So if you have 100,000 or 1 million kilobytes and you want to convert it into, that's kilobytes, and you want to divide, you have 100,000 or 1 million kilobytes and you want to convert it into gigabytes, then this formula will show you, because we'll use this 100 kilobytes is equals to 1 kilobyte. So if you have 1 kilobyte, so you start converting. So 1024 kilobytes is equals to 1 gigabyte. So you can, therefore, what about 100,000? What about 1 million? It's how many megabytes? You get the megabytes, then you take how many megabytes? You take the megabytes. So 1024 megabytes is equals to this. Therefore, what about this one? Then you do the mathematics and you get the value of the gigabyte. So it's very important that here there's a lot of mathematics. Once you know this, then you can convert it into any. You can convert to megabytes, to kilobytes, to bytes. If someone tells you I have 100 million bytes of data, what capacity of storage do I need in terms of kilobytes or in terms of gigabytes? Then you can convert based on this formula, based on this knowledge that we are talking about here. So the storage capacity of the CPU, the storage capacity of the CPU is called primary storage unit. Over the years, the storage unit has been called main storage. internal storage, primary storage, or memory. Primary storage provides for the capacity to store software in the form of operation system, application programs, and utility routines. It is in addition, the data input for processing is stored in the memory as the result of processing until they are output either to the back storage or to an output device such as a printer or visual display unit. Next, so we discuss the types of primary storage. Types of primary storage, they are the core storage, and then you have the semiconductor memory, the MOS. So the core storage, we go back a little bit to understand the history of the core storage. During the 15 years between 1960 and 1975, the dominant computer design used tiny rings or cores of magnetized material in the primary storage section. So current flowing in one direction produces a 0-bit state since the core permanently retained its magnetic state in the absence of the current. It was an non-volatile storage media. Core storage was popular for 15 years because it was safe, durable, and reliable very fast. But the new storage device that appeared in the 1970s offered even faster performance at a lower cost, and so the popularity of the cores quickly faded. For semiconductors, now this one is different. Virtually all computers made today usually use semiconductor elements in the primary storage section. It is produced from silicon chips and is based on two types of technologies. The first, i.e., the faster and more expensive, the bipolar semiconductor chip, and slower and less expensive, the metal oxide semiconductor. That's the MOS chips. So there are two types of semiconductor memory. So every smartphone has also these memories, like the random access memory, the RAM. This is the type of semiconductor memory. These are referred to as random access because any of the locations on a chip can be randomly selected and used to directly store and retrieve data and instruction. This type of memory can be both read to retrieve information and written into to store information. RAM chips may be classified as dynamic or static. So the storage cell circuits dynamic RAM chips contain the transistor that acts in much the same way as the mechanical on-off switch, capacitor that is capable of storing an electric charge. So depending on the switch action of the transistor, the capacitor either contains no charge, 0-bit, or does not hold a charge, that's 1-bit. Since the charge on the capacitor tends to leak off, provision is made to periodically regenerate or refresh the storage charge. So a dynamic RAM thus provides volatile storage. It means volatile means you can once this once you lose you switch off your computer, everything goes, or you lose electricity, everything goes. So it's volatile. Non-volatile means it permanently stores the data and it cannot lose the data even if there's power failure. That is even if there's power failure, it cannot. That is non-volatile. But volatile, that is the data stored are lost in the event of power failure. So static RAM chips are also volatile storage devices, but as they are supplied with the power, they require no special to retain the storage data. In real sense, the contents of the static RAM remain stable forever as long as power is available. So when power goes off, you hear that my computer has lost everything is because of this. They are volatile. We are not going to discuss this because we are just online, so I'm not, but it's something you look at it. You look online, we have groups online, so go to the forums and answer these questions, they are there. So the next thing we are looking at, this activity 4 is in a forum, so try to answer. I know MacD has passed you through the forums. So a read-only memory, the ROM, is a read-only memory that can only be produced by the manufacturer. The contents of the ROM are physically fixed and cannot be accessed to alter them as can be done with the RAM. So microprograms control instructions that cause the machine to perform certain operations are usually stored in the ROM. The contents of the ROM are not destroyed when the computer is switched off, as ROM is non-volatile because its contents have been burned in during manufacture. So ROM also stores the operating system. So for example, even if you have a TV and it is a Samsung, normally you will see that the Samsung will be displayed. The Samsung will be displayed. If you switch on a TV and it is Samsung, you will see Samsung being displayed. That one is stored in the ROM of that particular TV. If it's another, it's Huawei. Like for example, in your phone, when you switch on, it is Huawei. You will see Huawei. For example, again in your phone, if it is Android, you will see the different Nokia. You will see. So all those are stored in what we call the ROM. So once you switch on the computer, you will see they are permanent. So we have what we call the programmable read-only memory. There are versions of the ROM. The PROM stands for programmable read-only memory, whereas ordinary ROM is pre-programmed at the factory. PROM can be programmed by the user. So PROM can be programmed by the user. A special device is required for putting the bit pattern into a PROM chip. This is called a PROM programmer. What could be the disadvantages of the PROM? The PROM is because one of the disadvantages is because the programmer can even erase what is important, because now he himself can put the user. And if the user is a novice user, it will be very difficult for him to use this PROM. Then we have what we call the EEPROM, EPROM, the EPROM, not the the EPROM, which is the erasable programmable read-only memory. This is a further variation of the ROM, which stands for erasable programmable read-only memory. When data is recorded on this type of memory, it is in effect the same as ordinary ROM in its behavior, but if the user requires to change the contents of the chip, an UV light is used to revert all the cells to ones. So new data or programs can then be written on the chip. So what's the disadvantages of the EEPROM? Find out the EEPROM. Find out what are the disadvantages. Then we have the EEPROM. The electrical erasable programmable read-only memory is a user modifiable read-only memory that can be erased and reprogrammed repeatedly through the application of higher than normal electrical voltage. Unlike the EEPROM chips, EEPROM do not need to be removed from the computer to be modified. However, an EEPROM chip has to be erased and reprogrammed in its entirety. Not selectively, it also has a limited life. That is, the number of times it can be reprogrammed is limited to tens or thousands of times. In an EEPROM, that is frequently reprogrammed while the computer is in use. The life of the EEPROM can be an important design consideration. Then we have what we call the flash EEPROM memory. Flash memory is a type of non-volatile memory that erases data in units called blocks. A block stored on a flash memory chip must be erased before data can be written or programmed to the microchip. Flash memory retains data for an extended period of time, whether a flash-equipped device is powered on or off. So it means it's a non-volatile. Then now we go to registers. To understand how the above components, that is the control unit and ALU of the CPU works first, we need to first understand the registers, which are a special purpose temporary storage location within the processor and other devices within the computer system. They are quite separated from the location in main memory, although they can be similar in structure. The types of registers and their functions. So we have different types of registers. Registers might be classified into two groups: the register out of the processor and the register in the processor. So we have registers out of the processor. These ones, they work out of the processor. We have the memory data register. All data and instruction pass in and out of the processor through this register. The memory, so all the data that is passing and instruction pass in and out of the processor, they pass through the memory data register. The next one is the memory buffer register. All data instruction pass in and out of the memory through this register, the memory buffer register. Then we have the memory address register. Prior to each transfer between the processor's memory data register and main memory's buffer register, the exact source or destination of the data in the main storage must be specified. This is done by loading the appropriate location address into the memory address register. The main memory receives this address information through the address bus. It also receives control signals from the processor via the control bus, which is able to decode into command for it to save or retrieve data. So the data buffer registers, the DBR, another important register in the data buffer register on which input-output unit connects to the processor via a bus, also have these registers which serve as a similar purpose to the memory buffer register. So the registers in the processor, these are constructed so that the contents can be accessed and altered much faster than the contents of locations of main memory. So we have what we call the IR, which is the instruction register. This is the first register you encounter in the processor, where the next executable instruction is first taken from the main memory via the memory data register and placed. Once in the IR or the instruction register, the instruction can be rapidly decoded and executed. Note that the IR is also sometimes called the instruction register. So if somebody asks you what is a current instruction register and what is an IR, it's the same thing. So data registers, this register is within the ALU in which data to the processor, e.g. numbers about to be added are subtracted. That is placed from the main memory via the data register, memory data register. The required arithmetical logic is then rapidly performed. The ALU, which provides the results in one data register from which it can be taken and stored in main memory storage. So we have the status register. This is used by the control unit as a means of detecting conditions which have occurred, such as the ALU detecting the arithmetic error of dividing by 0. Primary components of the processor will now be considered in detail. So we have, for example, list the 3 types of processor registers and state their functions. That one you can do. I think I've just talked about them. Then we have what we call the bubble register. From the processor, we look at different types of memory called the bubble register. Bubbles may be described as cylindrical magnets which are formed from magnetic regions called the domain. After the application of critical bias value magnetic field, the bubbles are created on memory chips of thumbnail size with the capacities of typically 64 and 250 kilobytes. The ICL DN cell 200 digital PABX systems use bubble memory. So it seems that this type of memory is likely to be used widely in the future, especially the phones. The PABX is the phone. The phones the internet phones that can be able to call, they use that. Then the holographic optical memory. This is a ROM optical memory system where a pattern is recorded on a photosensitive plate by mixing lesser light from reference beam and lesser light scattered from the object bearing the information to be recorded. So the data in the hologram is effectively smeared over the whole of the plate. A degree of redundancy is built into the system so that dust and scratches on the emulsion have little effect on the recorded information. Data, the constructed image is arranged as an array of dots, 1 dot for each bit. Information may be read out by directing a laser beam on the hologram so that the reconstructed image falls onto the photodiode array on a silicon chip. At present, the main limitation is that information on the holograph stored is generally fixed and is presently of value for storing large amounts of fixed information, such as machine instructions. It is a high-speed memory. Now we go to what we call the cache. We go to what we call the cache memory or the cache. Sometimes people call it cache or cache. Cache, some call them cache, depending on your teacher of English. Depending on the teacher of English, cache is cache or cache. So this is cache memory, but it's cache memory. Is CACHE, cache memory. It's a high-speed memory capable of keeping up with the CPU. It acts as a buffer between the CPU and the slower main memory. As the CPU is not delayed by the memory access, the overall speed of processing is increased. So segments of the program and data are transferred from the disk back storage into the cache buffer by the operating system. This type of memory is mainly applicable to the larger computers. It means that in between, we have the storage. For example, in your phone, you have what we call memory card. Then in between, we'll have a cache. Between the main memory, we'll have a cache here that will help you. This data will be loaded so that when it's processing, it does not take long to access what is in the storage in the memory card. Actually, what's in the memory card is pushed to the cache so that everything that is in the cache is processed immediately. So that all the data moves to the cache. From the cache, then it's processed as instructed, as per the instructions in the instruction register. Then we have the buses. The buses are used for transport. Let us now look at a different item used in processing called a computer bus. A computer processor consists of 4 types of bus: address, data, control, and peripheral. A bus is a channel or pathway for the processor to another, including transferring data from the internal memory to the arithmetic logic unit. Buses are also called the channels for transmitting signals relating to the address of the data to be operated on, the input and output of and from specific peripheral devices, the transmission of signals for controlling all processing activities. So when you type on your smartphone, these buses are the ones which are now you are giving instructions, you are typing these, giving instruction, and you see the display. That helps in the instructions so that when you type A and you are seen, it sends instructions. Then it's able to show. Then it's able to send instructions to the bus is able to send to the output device so that you can see it on the screen. All those instructions are usually sent through the bus. And we said we have 4 types: the address, the data, the control, and peripheral. Peripheral, these are the buses that are able to communicate with the output and input devices. So like if you have a touch screen and you are giving instructions and you want to display on your screen, it must go through the peripheral bus so that it can show you what is happening. Now, after knowing these factors above, it's important for us to discuss each bus on its own and what it does. So we have the address bus. The first type of bus used in processing is the address bus, which is used to send address details between the memories and address register. The address of the data to be operated on the operand is stored in the address register. The number of channels on an address register, the larger the address register, the possible internal memory capacity, because the larger the number of addresses that can be generated, the value of the binary digit doubles each time the one moves into a higher order position, i.e. the left. So this follows from the binary progression of 2n. Then we have the data bus. These are the bidirectional buses that carry information and data to and from the microprocessor. The data bus contains the width of the microprocessor, hence the denotation as 8-bit, 16-bit, 32-bit. They are normally created by the microprocessor registers. Then we have what we call the control bus. These are the unidirectional buses that carry command signals from the microprocessor and sometimes the signals are to the microprocessor itself. The direction of the transfer on the data bus is indicated by the control signals from the control bus. So the peripheral channel, those facilitate the connection of the devices. So these ones ensure that all the devices, for example, the keyboard, the printer, the scanners, which are input devices, the mouse, actually they help in communication with this particular connection of that. So what is a bus? List the 3 types of buses and explain their function. We have talked about the 4 types there. And what is a bus? That's pathway. It's very important. So what is a bus? We have talked about it. After dealing mainly with the devices that concentrate on converting data information for ease of use, let us now move further to a new section that will enable the user to communicate with the computer by giving them results called the output devices. So we are going to look at the output devices. So in this section, now we are going to look at output devices. These are devices that are able to produce physically the data that you are actually looking for. Because if it is you wanted it printed, you will see a printout. If you want to see it on the display, you will see it on a visual display unit. If you want to hear you can get through audio or through from the speakers. Speakers are also output devices. When you listen to that music, that's an output device. The speaker is an output device. Just like a microphone is an input device, now the output device is a speaker. Speakers are also output devices. They are also output devices, so you need to know that. So in this section, we will discuss the various devices that can be used to give feedback to the user. The results of any form of data processing are output. An output device is a peripheral which shows the computer output either in soft or hard copy. The output can be used immediately or stored for later use. Output can take many forms. Output might be human sensible, which means that it can be recognized and understood by the human. It requires special machine for it to be accessed by people, e.g., computer output onto microfilm or microfiche, where microfilm or microfiche readers are needed to access the stored data. An output should also be computer sensible, with the output data or information stored for later processing by another computer. So the human sensible output consists of the printed output. Then we have the visual display unit. So we have the printers. There is an important output device beside the monitor. Generally, the printers fall into 2 categories. Printers can be classified by whether they print a character, a line, or a page type. So we have what we call the character printers. This one prints serially, 1 character at a time, much like a typewriter. As a result, speeds are very slow, 10 to 150 characters per second. They are relatively cheap and are commonly found in small business systems. When a keyboard device has a character printer attached, it is called a teletype or a typewriter. The keyboard acts as the input medium, the printer as the output device. So we have also called the line printers, are much faster devices which print a line at a time. Some are capable of printing up to 3,000 lines per minute. 3,000 lines per minute. They are accordingly more expensive. Then we have the page printers, print a whole page at a time. They are expensive and are intended to deal with very large volumes of printed computer output in large organizations. So printers can be classified according to their technology. Printers can also be classified according to their technology. So we also have what we call impact and non-impact printers. So impact printers require heating of inked ribbons against paper, like the ordinary typewriter. The impact printers are noisy in operation. So the impact printers are normally noisy in operation. So the technology they are using, they heat. There are some printers who just get tut, 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 tut. Those are now what we call the impact printer. And they are very noisy in operations. Then non-impact printers, such as the laser printers, use different technologies such as ink spray, heat, xerographic, or laser to form printed copy. Characters are not formed by mechanical impact. So there's no mechanical impact. So differentiate between impact and non-impact printers, look for more. But the main information that the impact printers, they are noisy in operation. These ones are not very noisy in operations. That is something that you can differentiate. So printers can be classified by quality of print they produce as below. So we have looked at classification based on the technology. We've looked at classification based on the line. That is based on the character, how they print their characters, a line or a page. So we have page printers on that. Then we have the technology impact on an impact. Then we have what we call now by quality of print they produce. So we have the dot matrix. They are impact printers, character printers that produce character prints in terms of dots. They print characters as an array of points or dots. The quality of print varies according to the number of dots that make up a character. However, it's a slow printer. We have the daisy wheel. It's the oldest kind of printer, which is an impact printer, works like a typewriter. When a piece of metal or plastic, the raised letter strikes an ink ribbon against a sheet of paper, leaving an image of the letter on the paper. Then we have the near letter quality, the NLQ. A printer offers NLQ is a printer that offers NLQ is one that provides a quality of print that is near but not quite as good as a typed letter. Additionally, printers can be classified in terms of speed. The basic types of printers will now be explained in detail. So we have the impact character printers. There are two basic types of impact printers, dot matrix and moving printer. That's the head or wheel. So the dot matrix printer prints patterns of dots in the shape of a desired character. Speed of up to around 165 characters per second are possible, but the print quality may be low. However, some of the dot matrix printers have the neat letter quality print. That's an example of the dot matrix. They are very noisy. If you go sometimes when they're printing receipts, sometimes they are used there and they're very noisy. Using a rotating or a pivoting ball as a print head, those are the ball printer. The printing characters are on the surface of the ball, which strikes a ribbon to transfer the characters onto the paper. This is the IBM Golf Ball Electric typewriter. Then we have the wheel or daisy wheel printer. Use a wheel as a print head with the characters forming a band around the circumference of the print wheel. To print a character, the wheel is rotated and a hammer strikes the back side of the spoke and presses it against the paper. So the daisy wheel, this is the daisy wheel. If you see it somewhere, that's the daisy wheel. Some balls and wheel printers can print left to right on the next, thus increasing the effective print speed. They print at a relatively slow speed, typically 10 to 15 characters per second. CPS means characters per second, but produce good quality print, i.e. full letter quality print, quality characters. So a dot matrix printer and a graphic plotter could both be used by a shop that designs and sells fitted kitchens to produce the kitchen plans on different paper sizes and using color. So explain which one will be better in that situation. Then we have an impact character. And impact character printers. These are printers that use other means to create image. Inkjet printers, for example, use the tiny nozzles to spray droplets of ink onto the page, while laser printers work like photocopiers, using heat to bond microscopic particles of dry toner to specific parts of the paper. So there are various types of non-impact printers. We have the thermal printers, create print images on special heat-sensitive paper by using heated wires in the print head, and they operate at the speed of 160 characters per second. Then we have the inkjet printers. These printers use the concept of spraying ink onto the paper, fire ink onto paper by using an electrostatic field. No special paper is needed, and the print quality can be good, but is not possible to produce multiple copies, and they can be unreliable. So you have seen this. I think at the gate there, I can see some of them use these printers. And then we have the line printers. They are mainly three types. We have the impact line printer. There are two main types of impact line printer. The print characters are mounted on a moving chain or belt or engraved on the face of a rotating drum. Typically, line printers speed range from 200 to 300 lines per minute. Multiple copies can easily be produced, and the characters are of layer quality. Then we have the non-impact line printers. The main non-impact line printer is the electrostatic printer. This places electrostatic charges in the shape of the required characters on a special sensitive paper. They are not common in business operations. We have the magnetic printer. A magnetic printer operates much like the electrostatic printer, except that the magnetic charges are placed on a belt rather than on a sensitized paper. Magnetic printers are much slower than electrostatic printers, and they print up to 200 lines per minute, but do not require a special paper. Then we have the page printers. Page printers are an impact, very high-speed printers capable of printing a page at a time. They can be electrostatic, xerographic, laser, electrostatic page printers. So the laser printers, mostly they do that, is a printer that uses electrostatic charges. The characters are created using tiny dots, 200 to the inch, giving a high quality, which does not look like matrix printing. The document outline is coded and stored for printing with the data when ready. Letterheads and logos can be created electrostatically using chargeable metal cylinders. Pre-printed stationery can also be handled. The xerographic printers, it is a printer that has an inbuilt processing power of production of multiple copies is possible. Production of multiple copies is possible. They are an adaptation of the xerograph office copier. Xerography is the process of electrostatic printing or dry photography in which negatively charged powder is sprinkled on a positively charged surface. So xerographic printer produces sharp character images on letter-sized paper. The printer usually has an inbuilt microcomputer and can produce and collect multiple copies. It operates at about 4,000 RPM per minute. So it is very fast in terms of printing. So then we have the laser printers. These are very common also. When you come mostly in your offices, will get these laser printers. They are probably the most advanced printers and use a laser beam to produce character images on the surface of a rotating drum. A toner that adheres to the light images is then transferred to the paper. Some laser printers are running at the speed equivalent to 21,000 lines per minute. So they are needed only in large volume application, e.g. mailing shots, price listing in major companies. So they are very common. Then we go to another type now, which is not a printer. These are plotters. A plotter is another output device. a plotter is an output device. A plotter is a device that produces graphical output on paper. It converts digital computer output into illustrations such as graphs, bar charts, pie charts, maps, and technical drawing. Mostly when you see the plans of houses, the lands drawing, when you see when they are printed, either for house or they use plotters. So a digital plotter plotter works by converting digital coordinates, or rather like map reference, into a pen movement. Alternatively, an incremental plotter sends signal to tell the pen how far to move from its present position. So plotters are not always directly connected to the computer because the pen output is fairly slow, thus wasting computer time. Rather, a program magnetic tape. The tape can then be run later by a small microprocessor, which is a reader, which will control the specialized plotter. So there are two types of plotter. You have the flat plate. If you go to the Ministry of Lands, and you can easily get these, and those who are architecture, those who draw house plans, you can get them with these plotters. But in the Ministry of Lands, mostly those ones that draw the maps of land and what they are, usually they use what we call the plotters. So we have what we call the flat plotter and a drum plotter. Mostly if you go to the Ministry of Lands, in any organization, like even in Bugoma County here, you will get a drum plotter, or you can get a flatbed plotter. This is fixed flat table or bed on which the writing pen can move over the paper up, down, and in the north, south, west, east direction, so they can move with that direction. So a drum plotter here, a roll of paper mounting on a drum can be moved back and forth whilst the pen moves across the paper. A combination of drum and pen movement allows a line to be drawn anywhere on the paper. So that is what we call.
Hello, Doc. Hello, Doc.
Yes. Yes.
Because
How are
of
you?
because of time, can we maybe allow, because I have another session that's starting exactly at 5, and I need also to prepare the link. Hello. So maybe we can allow students to revise whatever they have done. Revise whatever you have done and finish that topic. Because from 11 we have another class that's coming. So members, as I advise you, research and discussion are enough. Research and discussions are enough. So I advise you, once you have the notes, engage yourself in your research. Go to Google, go to YouTube, watch those videos. They will enhance that one. Okay. Then have a form a discussion group, form a discussion group specifically for this unit. Through discussions, the content will sync just automatically. Okay. So that's my advice. That's my advice. That's my advice. So other things we shall sort them later because of time. It's a lesson that I need to set from 11. Okay. Call it off.
We shall communicate the same in the next lesson, okay? We'll be able to
Shall we?
communicate the next lesson.
Senior, I was of my opinion that because I have another class from 11 that I need to prepare.
I went off a bit.
it was my opinion that maybe now we can call it a day. We
It was off a
resume
bit. MacD,
next
are you
lesson.
getting me?
Yes.
Yes. Yes.
McDonald?
Yes, I'm getting you.
Yes, I'm
MacD, are
getting.
you?
Yes. Yes.